In the second part, we will study the conditional probability. Now, first, let us suppose that we roll a single die, and as you all know that whenever we roll a die, we will get 6 outcomes: 1, 2, 3, 4, 5 and 6. Let us suppose an event that 6 will occur. It means that we are interested that the outcome should be 6. So, how many sample points favor this event? It's only one sample point in the sample space which is favoring the described event. That outcome will be 6. So, what will be the probability of A? By applying the probability of an event definition, it would be equal to number of favorable outcomes divided by total number of outcomes, which will be equal to 1 by 6. Now, what's happening next? Let's suppose some additional information has come that whenever we roll a die, an even number will occur. So, if only even number will occur, it means it will reduce our sample space to 2, 4 and 6. Now, as we got an additional information that the outcome is an even number, so it will definitely affect our probability of an event which we described as A, and it is equal to 6 will occur. As we know, the probability of an event is defined as number of favorable outcomes divided by total number of outcomes. So, if we go through this reduced sample space, the new probability of the described event, that is probability of A, will be 1 by 3. So it has increased the chances of occurrence of an event as an additional information came to us. So what is conditional probability? Conditional probability is the probability of an event occurring given that the other event has already occurred and is denoted by probability B given A. Now let's just go back to the previous example. What's happening here? Some event is occurring, that is 6, and some additional information came or additional event came that the outcome is an even number. So, whenever we have some given information, or you can say an additional information before finding the probability of an event, and it is also helpful in increasing the chances of occurrence of an event, and so this one is called the conditional probability. So mathematically, what is it? The probability that B occurs given that A has been occurred or A has already occurred will be denoted by probability B given A, and it will be equal to probability A intersection B, or you can say probability A and B divided by probability of A, where probability A intersection B is joint probability of A and B, where probability of A is a marginal probability of A. As we are studying conditional probability, so it means there should be some known information as we have described in previous example and definition as well. We are trying to find the probability of A given that B has already occurred. It can be read as probability of A given B, where B is known and A's probability we have to find. Like we know the probability of B and we have to find the probability of A. Example number 1, referring to the previous example as we have discussed in previous slides, find the probability of selecting an unemployed adult given that an adult is male. So let's go to the previous slide. What we are doing? We have to find some probability given that some information is already there. We have to find the probability that the selected adult is unemployed. It means it's A. Given that the statement after given that information, given that statement is the information that already occurred or it is an additional information, and it would be denoted from here is B, which is known. So given that an adult is a male, as we have defined unemployed as U, M as male in previous slides. So by applying conditional probability U given M, as we have to find the probability of unemployed adult given that he is a male is equal to probability of M intersection U divided by probability of M. We have already calculated in previous slides probability M and U is equal to 40 by 900. As you can see from this table again that the persons who are male as well as unemployed are 40 and total number of persons or individuals are 900, and the person or individuals who are male in this data are 500. So it would be equal to 500 by 900 by applying conditional probability M intersection U divided by probability of M. It will be equal to 40 by 500. Example number 2. The probability that a regularly scheduled flight departs on time is probability D is equal to 0.83. The probability that it arrives on time is probability A is equal to 0.82, and the probability that it departs and arrives on time is probability D intersection A, which is equal to 0.78. Find the probability that a plane, part number A, arrives on time given that it departed on time. Part number B, departed on time given that it has arrived on time. As we have defined that given that information has changed the criteria, now we have to go to the conditional probability, as we have given some information which already happened or already known. So it would be helpful to find out the probability of the given event. So part number A, arrives on time given that it departed on time. As we know, A represents it plane arrives on time and D represents it departed on time. So by applying the conditional probability formula, it would be equal to probability A given D, which will be equal to probability D intersection A divided by probability of D, which would be equal to 0.78 divided by 0.83, which would be equal to 0.94. Similarly with the part B, departed on time, given that it has arrived on time. So we have to find the probability that it departed on time, which represents with the event D, and A represents it arrived on time. So by applying the conditional probability, it will be equal to probability D given A, which will be equal to probability D intersection A divided by probability of A, which would be equal to 0.95. Example number 3. Consider an industrial process in the textile industry in which strips of particular type of cloth are being produced. It is known from historical information on the process that 10% of strips fail the length test, 5% fail the texture test, and only 0.8% fail both tests. If a strip is selected randomly from the process and a quick measurement identifies it as failing the length test, what is the probability that it is texture defective? Now the thing is changed here. What? Given that word is not used here. Up till now we are saying that given that the information after the statement given that is the given information or additional information. But here in this example, given that word is not used. But if you pay attention to the last 3 lines of the example 3, what it's saying? If a strip is selected at random from the process and a quick measurement identifies it as failing the length test, it means it have already identified that the randomly selected strip has failed the length test. What is the probability that it is texture defective? Now you have to find the main thing. क्या probability है कि texture defective भी है? वो information आ गई है आपके पास कि वो length test fail कर चुकी है. So here we will again apply conditional probability because obviously this additional information is useful in it. So let T represents that it is texture defective. L represents that it fails the length. So by applying the conditional probability formula, it would be equal to probability T given L. As we have to find the probability that it is texture defective, so it will come first. And where will L come? It will come after given that. It means T given L, because we already know that it fails the length test, which would be equal to probability T intersection L, means it is texture defective as well as it fails the length test. You can see from the above slide that 0.8% are the one who fails the both test, and probability of L, it means it fails the length test. How many are they? They are 10%. So it would be equal to 0.008 divided by 0.1, which would be equal to 0.08. Now what's happening here? What is the probability of rolling a die? It means a die is rolling here in the experiment. And what it's asking? It's asking its value is less than 4. Okay. But something is here in green lines. Knowing that the value is an odd number, it means some information has already come. In blue, what is it? As you can see the text written in blue, it is mentioning that the event in which you are interested, of whom probability you have to find. But what this text indicating in green? It's indicating that this is an additional information or given information. So what we know? We know that whenever we roll a die, we will get 6 outcomes. 1, 2, 3, 4, 5, 6. And we have two events here. The first one is in blue, that the outcome is less than 4. The second one is in green, that the value is an odd number. Let A represents the value as an odd number, and let B represents that the outcome is less than 4. So what's this diagram is indicating? This green lines or green green area shows that the outcome here will be odd number, and odd numbers are 1, 3 and 5. And what this blue area is indicating, that the die's outcome are less than 4. If we have 6 outcomes, 1, 2, 3, 4, 5, 6, then how many outcomes which are less than 4? 1, 2 and 3. Now, you can see that 1 and 3 are common in both. It means they possess the both characteristics, like they are odd number as well as they are less than 4. So by applying conditional probability, probability B given A is equal to probability A intersection B divided by probability of A, which would be equal to probability A intersection B 2 by 6 and probability of A 3 by 6. It would be equal to 2 by 3. We can see here number of times visited tutoring. There's some information of the students. Some are full-time students, some are part-time students, and they are indicating that how many times they go to the tuition, 1 or fewer times, 2 or 3 times, 4 or more times. Now full-time student goes, 12 students goes 1 or fewer times to the tuition, 25 goes 2 to 3 times, 8 goes 4 or more times. So there are 45 total full-time students. And in the second row, you can see that there are 2 students who go to tuition 1 or fewer times, 5 students who go to tuition 2 to 3 times, 6 students who go to tuition 4 or more times. So there are 13 such students who go to tuition. Now what you have to find? Find the probability 4 or more times goes to tuition, given that the selected student is a full-time student. Like we can say that what is the probability that, or we can say that if we randomly select a student, so what will be the probability that he or she will go 4 or more times to the tuition, given that he or she is a full-time student. So we have to find for 4 or more times, given that full-time students, which is equal to how many students are there which have both characteristics, who goes to tuition 4 or more times and are full-time students as well. There are 8 students. And how many students are there who are full-time students? They are 45. So the answer is 8 by 45.